Right now, every message you send between Europe and Asia is traveling through Egypt, not by satellite, not across the Atlantic. The Atlantic has 100 cables, redundant and safe. The real internet between continents converges in one place, a strip of Egyptian desert, and a gap of water 26 kilometers wide called Bab el-mandeb. 3 anchors hit the wrong cables there last year, and a quarter of all data between Europe and Asia went dark. This is the choke point nobody talks about. Let's start with the scale, because it's hard to believe. Around 99% of all the data that crosses between continents, every message, every video call, every financial transaction, every cloud service, runs through undersea cables. There are roughly 570 of these systems in service, stretching nearly 1.5 million kilometers across the ocean floor. Satellites carry a rounding error by comparison. The cloud isn't in the sky. It's underwater. Now, why does that make it a choke point? Because to reach land, the cables have to come ashore, and in a handful of places, the world's geography forces dozens of them through the same narrow gap at once. The single biggest one is Egypt. More than 90% of all the data moving between Europe and Asia crosses Egyptian soil, where the cables briefly leave the sea and run overland between the Mediterranean and the Red Sea. Just south of there, everything funnels into the Strait of Bab el-Mandeb, a gap only about 26 kilometers wide that carries an estimated 1/6 of the world's internet traffic. 2 narrow points and half the planet's data depends on them. So who controls this system and who can break it? Increasingly, the cables themselves belong to a few giants, Google, Meta, Microsoft, and Amazon, who together use around 70% of international capacity. But ownership isn't the fragile part. The fragile part is repair. When a cable breaks, the entire planet depends on a fleet of only about 60 cable repair ships, carried, many of them decades old, and cables break constantly, roughly 200 faults every single year, the vast majority not sabotage, but ordinary fishing gear and dragged anchors. A single deep sea repair takes about 40 days on average, and where there's conflict or red tape carried, it stretches into months, and lately the breaks have stopped looking accidental. In September 2025, cuts in the Red Sea disrupted up to a quarter of all traffic between Asia and Europe at once. In the Baltic, ships have dragged anchors across cables between Finland, Estonia, and Sweden. Around Taiwan, lines to outlying islands have been severed again and again. Most cases are officially ruled accidents, and that's almost more unsettling because it means this system fails all by itself without anyone even trying. So what actually happens if several go down at the same choke point? You don't lose the internet, but a whole region slows to a crawl. Latency spikes. Cloud services stutter and time out. Banking, hospitals, governments, everything that quietly assumes an instant connection starts to grind. Traffic reroutes the long way around and congests what's left. For weeks. And here's the part that should keep you up at night: we have no real backup. There aren't enough ships, the spares are thin, and you can't lay a new transoceanic cable in an afternoon. We built the nervous system of human civilization, and we hung it on a few hundred strands of glass in the dark, at the bottom of the sea, defended by almost no one. The most connected species in history is one well-placed anchor away from going quiet, and consider how slow the fix really is. When a cable fails, operators first have to locate the break, sometimes thousands of meters down in total darkness, then dispatch one of those few aging ships, which can take days or weeks just to reach the site. The vessel drags the seabed with a grapnel, hauls the cable up, splices in a fresh section by hand, tests it, and lowers it back, a painstaking operation that a single storm can stall for days more. There is no overnight patch, and we are falling behind. Replacing the world's cable ship fleet would cost billions, yet new orders are a trickle, carried while demand for data explodes with cloud computing and artificial intelligence. So every year we lay more glass on the ocean floor and depend on it more completely, even as our ability to guard it and repair it slips further behind. The gap between how much civilization leans on these threads and how little stands ready to protect them widens with every passing month. And almost no one is paying attention. This is single point of failure. If this changed how you see the map, subscribe. There are 100 more of these.